All right, guys, so yesterday we started talking about simplifying rational expressions. Today we're going to deal with rational exponents, and really it's just a change in form. The definition below says if you have some number b to the p over q, so our exponent's a fraction, p over q, where if you notice we have the radical symbol, the square root symbol is what we normally call it. Well, normally if we just had a radical symbol, that q would be a 2, but we could put any number in there. So q square roots of b to the p. Or you could have it written with parentheses and the p outside of the parentheses. Guys, all it is transforming. If you look at the examples right below this, we have that the square root of x is equal to 1/2, or x to the 1/2. Since it's just the symbol, that implies there's a 2 there. Since there's no exponent, it implies there's a 1. It's your 1 over your 2. You can see it in the next one. This time it's a cube root of x. That's three roots of x. And since there's no exponent, that means there's a 1. And again, this becomes the numerator in the exponent. This becomes the denominator. And then the last one, it has an actual exponent that's different than 1. This is 3 roots of 2 to the 5th. The 2 ends up being the base. Again, the 5 becomes the numerator. The 3 becomes the denominator. So a lot of these guys are just going to be transferring one form to the other. Let's look at some examples. It says, use the definition to simplify each of the following. We're going to simplify these, and then we're going to put them in our calculator. The first one I have is 3 roots of 125. Remember, there's actually a 1 out here, so we need to remember that. So all I have to do is follow my formula. What's inside the root or the radical symbol, we write first. We take the number after it to the right, that's our numerator. We take the number before and use it as our denominator. So the answer is 125 to the 1/3. Now we can put that in our calculator. When you do, you'll put in 125, you'll hit the caret button, and you'll put 1 divided by 3. You should get, if you put that in there correctly, 5. If you didn't get it, sometimes you need to put parentheses around your fractions, but that should be an easy fix. The next one, I have 4 roots of 16. Since there's no exponent on the right, that means it's 1. So I'll do the same thing I did last time. The 16 is my base. The 1 becomes my numerator. The 4 becomes my denominator. Again, we can put that in our calculator. 16, the caret button. Let's just go ahead and 1 divided by 4. If you do that right, you should get 2. So check your calculator stuff. Make sure you can do that. And you can see, I mean, you got to remember the formula, but transforming, it's really not hard. So keep that in front of you, and eventually you'll just have it memorized. Let's look at some more. This, it says convert to radical form. That's doing the opposite of what we just did. The first one gives us 12a to the 2/3. Now you have to be careful here. Since 12a is not in parentheses, that 2/3 only belongs to the a. So when we write our next step, I'm going to put the 12 out front, then I'm going to convert this back into to a radical form. So I know that the formula says that this is the exponent that's on the right. This is the one that's how many roots. So I'm going to say 3 roots of a, my base, squared. And that's all I can do. So look at your formula, use it. Don't get p and q mixed up. I mean, if you had the square root of a to the 3rd, I could sort of understand that, but you have the formula in front of you guys, you need to use it. Let's move on to number 4, 16 to the 3/2. This one's a pretty basic rewrite. I'm going to put my root symbol. The 2 is in the denominator, so that goes right here. And really, you don't have to put the 2 because that implies square root if there's no number there. I put 16 inside, and then I put to the 3rd outside. Now, we could put that in our calculator also. You just do the square root of 16 cubed. If you do that right, you should get 64. So far it's just transforming, a little bit of calculator. Number 5 adds in something different, and that's a negative exponent. Now, if you don't remember, if I have like x to the -1, that's equal to 1 over x. So I just move it if it's in the numerator, I move it to the denominator, and the exponent becomes positive. If it's in the denominator, I move it to the numerator, and the exponent becomes positive. So I have 27 to the -2/3. I'm going to go ahead and rewrite that. I'm going to put my 3 out front, square roots of 27, but that's to the -2. Actually, guys, let's do it this way. I'm sorry. Let's get rid of the negative exponent first. Sorry, if you want to go ahead and erase real quick, that's fine. I'm going to go ahead and fix this first. I'm going to put it 1 over 27 to the 2/3. I think that'll make it a little bit easier. Now, if we have 2/3 on the bottom and 1 on top, that's really the same as having 2/3 up here, because 1 to the 2/3 is 1. So I'm going to rewrite that. The 3 is my denominator, so I'm going to use that out front. I'm going to open my square root sign, but this time I'm going to just put in 1 over 27, and I'm going to square it. So that one's a little weird. Be careful when you're setting it up. You could have done it the way I was about to do it and do the negative exponent last. Sometimes just getting rid of it first will make it easier. So there's our answer. Now we could also put that in the calculator. It's a little more complicated. On your calculator you have a button that's close to the square root button, and it has like a little dash right here in the square root. That would be where you can enter that in. If you can't find it, I believe it's in the math options. But if you do that one, you should get 2/3. For all my purposes, if you leave it like that, we should be just fine. And then the last one on this page, in parentheses, 9 over 25 to the 1/2. Well, I can just put the whole thing into the square root. So I'm going to put 9 over 25, open up my radical. I have 2 out front, 1 at the back. So really it's just the square root of 9 over 25, which equals 3/5. So far, guys, it's all about rearranging. I would be careful with some of them that turn into fractions like 5 and 6, but just follow what you see on the notes and you should be just fine. Let's go to the back page. We got 4 more. I realize it goes from number 6 to number 3. Just don't let that bother you. The directions say express in simplest form using positive rational exponents. What that means is we're going to do all the stuff we've been doing. We just may need to get rid of some negative exponents as well. So number 3, I have in parentheses 6 roots of 27a to the negative 1b squared, close parentheses, to the 4th. The first thing I'm going to do is rewrite it. Everything that's under that radical sign is like the b in our formula. So I'm just going to go ahead and write 27 a to the first, or a to the negative first, b squared. But I'm going to go ahead and put that in parentheses, because that's a whole big expression. I don't want to attach anything to just one piece. And then I'm going to rewrite the exponent. Let's see, that's going to be 4 over 6. Now, that part should not have been bad. That's just like what we did on the first page. You just got to remember that whatever's in that square root is all together. Now I'm going to go ahead and simplify the exponent, because I can simplify 4 over 6. That's 27 a to the negative 1b squared to the 2/3. Now, it's been a while since we've done this, but we're going to raise things to a power. And when you raise things to a power, you multiply the exponents. So that brings us to our next step. The first one is 27 to the 2/3. I'm going to have a to the negative 1 times 2/3, and b squared times 2/3. Now I just need to write all that out. Let's see, 27 to the 2/3. You can put that in your calculator. Be careful when you do. You might put parentheses around its exponent. If you do it right, you should get 9. A to the negative 1 times the 2/3 would be a to the negative 2/3. And then b squared times 2/3 would be b to the 4/3. Remember, when you multiply whole numbers by fractions, you just do it to the top or to the numerator. Now I'm going to fix my negative exponent. I'm just going to move all this to the bottom. So I have 9b to the 4/3 over a to the 2/3. And that's your answer. Now, guys, there's a lot of easy ways to make mistakes there, but you have to try. If you're not going to try it, I can't give you many points. If you're at least attempting it, I can give you some credit. Let's go ahead and look at number 4. I have the square root of x times the cube root of x times 6 roots of x. I want to go ahead and rewrite these, because this is actually not a very bad problem. If I have the square root of x, that's really a 2 here and a 1 there. So that's x to the 1/2 times, I can do the same thing on the next one, but it's x to the 1/3 times x to the 1/6. Now, a minute ago on number 3, we were raising powers to another power, so we multiplied them, but now we're multiplying, so we're going to add them. But to add those fractions, I need them to all have a common denominator. Now, you could get around this, guys, by just putting 1/2 plus 1/3 plus 1/6 in your calculator. But I can tell 6 is a common denominator, so I can change 1/2 to 3 over 6, plus 1/3 would change to 2 over 6, and then 1/6 wouldn't need to change. Now I'd add the numerators. 3 plus 2 plus 1 is 6 over 6. So I have x to the 6 over 6, which is really x to the first. So guys, remember, you can put fractions in your calculator. If it gave you a decimal, you'd probably do math enter to go back to a fraction. Generally, when we have fractions, we want to keep it that way. All right, guys, so that one's not so bad. Let's go on to number 5. Now, number 5 is really a distribution problem, and once you do, things clean up really nice. I'm going to have to distribute this 3x to the negative 1/3 to both of the terms inside the parentheses. So now we're again multiplying things, so we're going to add our exponents. So I have 3 times the 1 that's in front of that x is just 3. Then I have x to the negative 1/3 plus the 1/3 on the inside. Negative or positive 3 times the negative 4 is negative 12. And I'm going to have x to the negative 1/3 plus 4/3. So I just added the exponents, and that's all I'm going to do on the next step. Now I have equals 3x. Well, guys, negative 1/3 plus 1/3 is 0. Then I have minus 12x, negative 1/3 plus 4/3. 4 minus 1 is 3, so I have 3 over 3. And now I can clean that up. Guys, it's been a while since we've talked about this, but anything to the 0 equals 1. 3 times 1 just leaves me 3. And I have minus 12x. I'm going to put to the first because 3 over 3 equals 1. And there's your answer. So you got to remember these exponent rules. I know it's been a while, but if you remember them, it really isn't very bad. If you need some review on them, guys, we can. There are some videos on YouTube over it. You can always come and ask me. We've got one more, number 6. I have in parentheses the square root of 3x, close parentheses, to the 6th, and then the same thing on the bottom, but to the 10th. So I'm going to rewrite these, but the parentheses are important. When I take the 3x out, it needs to be in parentheses also. Now, I know I really have a 2 here, so my exponent would be 6 over 2 divided by the same thing, except instead of 6, I have 10. So 10 over 2. Now, I can clean this up, and you may think this is going to be a rough problem, but it really isn't. This is really 3x cubed over 3x to the 5th. So since I have 1s on those x's, I can bring those exponents in. I just have to raise everything to that power. So I have 3 to the 3rd, x to the 1 times 3, over, I'm going to put parentheses so it looks better, over 3 to the 5th times x to the 1st times 5. Now, we can put 3 to the 3rd in our calculator. If you do, you'll get 27. And then I have x to the 3rd. And that's over 3 to the 5th is 243, and I have x to the 5th. Now, you can put 27 over 243 in your calculator. You can simplify that. Obviously, it's 3 cubed over 3 to the 5th. So you could put in your calculator, do math, enter. You could also think of it like this. That's 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. Well, 3 of those 3's would cancel. It'd leave me 1 on top. And on bottom, I'd have 3 times 3, which is 9. We can simplify the x's the same way. X times x times x over x times x times x times x times x. 3 would cancel, and it would leave me x squared. So guys, this is not the easiest thing in the world, but it's not going to get any easier if you don't try, you don't get help, and you don't practice. So if you need help on this, you've got to come get it. Good luck.